The Estonian Demonstrator is a 3-story apartment building with 24 apartments. Each of these apartments are privately owned, and the building itself was constructed before 1990. The building has very high energy consumption and the indoor climate needs improvement. The Estonian Demonstrator apartment building typology is the most common among apartment buildings constructed before 1990 in Estonia. This gives this solution highest potential for replicability. In the Estonian Demonstrator, we will realize a deep energy renovation with prefabricated timber frame panels, where some of the facade will be covered with BIPV panels. These prefabricated panels will be designed for assembly, disassembly and reassembly. And within this Drastic Project, we will test the disassembly and reassembly. One of the challenges that we are facing in the Estonian Demonstrator at the moment is how to solve ground source heat pump with horizontal system, while in that specific location, the vertical system is not allowed.
The goal of the French demonstrator is to prove the potential for reuse of interior space plan product when an office retrofit is done by identifying circular business model allowing fast market uptake and positive environmental impact. To reach this goal, Saint-Gobain Solutions France, Coramin and Ecofun will test together the reuse of ceiling and partition in an office building in Paris in collaboration with ICAD. Saint-Gobain Research Paris plays a key role in the technical development of tools to ensure on-site diagnosis and performance of solutions and in assessing their social acceptance.
Our demonstrator is important as two recent developments in France will impact in the near future the potential of reused materials. First of all, new regulation in France is now forcing new buildings to calculate their carbon footprint per square meter. In this calculation, reused products account for zero. Reusing products in buildings becomes therefore a competitive advantage. In addition, the new extended producer responsibility forces an increasing level of reused products in order to reach 4% in 2027.
Reuse today comes with strong barriers. It needs new methods to selectively demount and disassemble the products, test the quality and ensure their performances, and effectively match demands and supply. Those are the key challenges that we want to tackle with our French demo sites. In our demonstrator, quick on-site diagnosis of the product will be developed, including dimension, a first visual verification, and an assessment of the reuse potential. Technical properties, acoustic, indoor air quality will also be checked to enable the best possible reuse of our products.
Drastic is a great opportunity to tackle and solve these challenges in this demonstrator, but also in the 4 others included in this European project.
I'm working as an R&D technology manager at Saint-Gobain Weber, and we at Weber, we produce all different kinds of construction products. Our demonstrator is representative for many German apartment buildings which need an energy efficiency upgrade. Therefore, we use attic systems in Germany, so external thermal insulation composite systems, which have the lifetime of 50 years plus. The different layers must stick together to ensure that long lifetime, and this is, you can imagine, contrary to the circular economy approach. Therefore, we want to improve the system by reuse as much as possible. For the reuse, we must ensure that it can be separated without harming all the different parts. Our approach is to reduce the gluing or to remove the gluing and just use a mechanical fixing by the anchoring. And additionally, we have a pull-off mesh for the render layer to remove the render layer without damaging the mineral wool. So the wool can be reused directly. And this is our approach. We want, on the one hand, materials which have the lowest environmental impact. So we want to use as mortar material which low amount of virgin raw materials. We want to have a high recycled content. We want to reduce the carbon footprint of the mortars by using alternative binders. And additionally, we want to have this mechanical fixation to reuse as much of the materials as possible. In our case, the mineral wool, the anchors, and potentially the mesh. And the remaining parts, like the render layer, we want to recycle in the second generation of the mortars as an aggregate. Therefore, we want to close the cycle to make the system more sustainable. Thank you very much.
The Norwegian forests, vital to our health and well-being, are at the frontier of the green shift. Through the Drastic Project, we harness its natural resources to transform the timber construction. However, we can go one step further. Instead of using virgin wood, we can find destinations for underused timber. Our mission at Amtre is to protect these vital ecosystems by harvesting timber from unused structures and by bringing it back in the loop. So to deal with one of the big challenges in reusable construction, which is complexity and coordinating this and integrating this, we have to work with a very multidisciplinary team, which we have in Amtre and also in our partners. And together, we are actually developing and testing these processes. For us, it is important we work with easy tools like a phone, not only for communication, but also for detecting and diagnosing on site. Each evaluation of a possible donation building uncovers potential for reclaimed timber. But not all buildings are destined for deconstruction.
Hi Wendy! The 3D scan I took of this barn turned out great, and it seems like this is a potential donation building.
The uniqueness of reclaimed timber is a challenge, which requires us to be adaptive and creative. But in Amtre, we have experts in wood technology, building physics, digital technologies, environment engineering, among others, to turn this challenge into an opportunity.
The barn timber is almost ready to be shipped to Estonia, where Taltech will do the technical testing.
Our vision extends beyond repurposing wood. In Drastic, we are integrating solutions like productive smart connectors to allow multiple uses of this reclaimed timber.
I've just been working on the Drastic pilot demonstrator here. The reclaimed timber for the columns could be really interesting. If this was barn timber, we could start to think about how we start to join it at the top and the bottom here.
So with Drastic, we want to prove that with the right approach, the right people, and the right integration, reclaimed timber can have multiple lives and create many new beginnings.
I have a very close relationship with both Productive and Amtre in this Nordic project, and I was chosen to help to integrate the new technologies into this demonstrator. We are building a shed, which will be the first full-site structure that uses Productive's design for disassembly framing system and Amtre's new methods for reclaiming waste wood into new buildings product material. But this shed won't be demolished when we are finished with it. Using Productive's click system, it can be taken apart without tools down to the original parts. Many of these parts can be reused for new projects, the universal corner C-joints. Even the panels and beams can be flat packed to new location to be rebuilt into different structure. Materials that won't be reused will be cleanly separated and can be recycled at much lower expense. This is circularity defined, collecting materials from old structures and implementing a new method of construction which allows for reuse of many components and efficient recycling of the rest. Construction, demolition and waste is a big source of carbon footprint, and we are on the case.
We have a dual role in this project, in which, in one hand, we will reuse structural elements from an existing building, and on the other, provide white slabs as a substitute for clinker in cement. Our demonstrator is located in Spain, and the final structure will be built in Balaguer, in Zurigue's facilities. Talking only about the slabs, as I mentioned, we will substitute a percentage of the clinker in the cement for our white slabs. White slabs is a byproduct originated in our process, and us as steel recyclers want to find other lives for what others would consider waste that comes out of our production process. This will result in a more sustainable built environment because instead of harvesting raw material, we will use a co-product that is originated in the process of making structural elements, which are also needed in the building sector. In this demonstrator, we would like to address the challenge of expansiveness in the white slabs. Because of its compositions, it's a very highly expansive material, and with this project, we would like to find the perfect proportion of substitution of raw materials to be able to have a more sustainable final building.
Bienvenidos a la Central Térmica Litoral de Almería. Welcome to the Littoral Thermal Power Plant. I am part of Lezama Demoliciones, the main contractor of the complete demolition of the facility. Our task, in addition to carrying out the demolition, is to innovate work processes and develop integrated waste management.
The Spanish demonstrator that Lezama is representing follows the aim to reuse structural steel profiles to develop a secondary material production capable of supplying the current and future construction market. In addition, a recycled concrete formulation in cladding up to 30% white steel slag will be developed and used in the new construction. The new structure is already designed on the basis of the parts to be reused, and the donor structure has been mapped and assessed for dismantling and transport. This demonstrator will allow verification of the capabilities of the new reuse market, which will guarantee a reduction in CO2 emissions and an improvement in the environmental performance of the construction sector. The companies that make up this consortium are Lezama Demoliciones, in the role of dismantling company, Celsa and the Polytechnic University of Catalonia as analyzers of destructive materials, and Sorige as the company in charge of the design and assembly of the new building.